Welcome to our autonomous car project. This video is going to show the process we used to build the car and the concepts behind it.
Let's start by showing you our final product. This project represents around 100 hours of work, and we're very excited to show you how far we've come. So this is a car that uses GPS waypoints to go to its location, and it did. It followed the GPS waypoint and adjusted based on its bearing and the azimuth from the compass.
So what was the objective of our project?
To set waypoints and have the car go to them, and then eventually it searches the area based on the coordinates that we set, and it's supposed to go to all the coordinates. So we added a GPS which provided us with the latitude and longitude, which we used the LCD screen to display those values. We also have we also added a speed controller which controls the speed of the DC motor using pulse width modulation and digital microseconds. And then we use the receiver to actually power the servo, because the speed controller is hooked up to the battery, and then we connect those and then connects to the servo. And then we mounted the LCD screen with a 3D printed mount on the back of the car. Now let's look at the journey that we took through this project. We're going to highlight some key progress updates that we had, and also a lot of problems that we ran into as well.
Our project had multiple ups and downs. Following are some clips that show the highlights and some of the lows that it took to make our car run perfectly.
We're testing the longitude and the latitude of the GPS and see how accurate the change is. Now it's driving to this not at the waypoint, so it's going to try and get there and stopping it.
So there's the ultrasonic sensor. I just set it up. You see it works when I move it. The number is small. I move it away from something, the number gets bigger. And over there we got Jake in the usual posture, outside, away from as many metal objects as we can be, trying to calibrate our terrible compass that thinks that there's less than 90 degrees between north and east, and that north is south and south is north. Probably hour number 5 of pure compass shenanigans. What if I do that?
Dude, we're going to have to put an interrupt in there. Look, you should have turned red by now.
It's supposed to be turning to the right.
Wait, why did it not? What?
Hey! Let's go. You think that's about 2.5 meters?
Yeah.
Our code works through a long system of functions. So I'm going to go through to explain the code and basically elaborate on some of the functions. So the way the car works is it has several sensors. It has GPS, ultrasonic, and compass. So we first update and display the compass settings. It's mostly just update the and display parts of these functions were namely used for when we first implemented them. We wanted to print out to the screen to make sure the values were correct. So anytime I say a task and then display, the display is commented out, only used for troubleshooting, but we kept the name. So an example would be the update and display GPS function. Update and display GPS, it just reads the information from the GPS and it saves it in a variable name, so we can use it to compare the desired lat and long to the current lat and long. Of course, when those values are within our tolerance, the car knows that it's at the waypoint and it will stop. The reason for the tolerance is because the GPS is off by about 2.5 meters, or the numbers are randomly distributed in a range of 2.5 meters around the car. So this allows it to compensate for the variance in the values. Next, we have the drive straight function. It does exactly what it sounds like. It causes the car to drive straight. It basically sends a PWM signal at a determined time of about 1680 microseconds, and that sets the car to a pretty solid pace. It's fast enough to drive through grass, but not fast enough that it drives away from us when we have to chase it. We have other functions like turn left and turn right, which, as they sound, make the car turn left and turn right. We call these functions based on the difference in the angle between the desired heading and the target heading. So depending on the sign of the difference, the car will steer a different way, and to steer it calls the turn left and turn right functions. Up next, we have the update and display distance and update and display compass. They're very similar to the update and display GPS functions. Update and display distance gets the data from the ultrasonic sensor on the bumper of the car, which prevents it from crashing into things and helps you pick it up by waving your hand in front of it. Update and display compass just gives you the values or the heading, basically the azimuth, the angle from north, and you can use that to compare where the car is going and know which direction it's facing. The stop function just sets it to a neutral PWM. To keep the car from moving, we call this function when it gets to the waypoint, and the difference between the lat and long and desired lat and long are within the tolerance. The update steering function is used to get the values from the steering, and it's based off the target bearing value we calculated in a different part of the code. The check distance and stop implements the ultrasonic sensor. It takes the information from the ultrasonic sensor based on a predetermined value. It will stop the car if the sensor gets to that value. Our value is currently 5 centimeters, so if the ultrasonic sensor reads a value anywhere lower than 5 centimeters, the car comes to a stop. That's our code.